You can all remember what we did last lesson. So previous or prior to 7G, we were on 7F, where we were looking at interpreting your R squared value. And on top of that, 7F was quite long because we were also looking at, I think, making the formula. So figuring out how to write the formula and drawing the line. So there's three things there that we did as a class. So we drew the line, we found the formula, drew the line. I'm not sure which order that would have been, and then we interpreted the R squared value, which remember is not the same as the R value. Okay, the R squared value is based. It's if you think of it as a measurement of how good the line represents the data. Okay. And from that as well, we interpreted the R squared value. So this is the sentence. Actually, I'll highlight it here. This is the sentence we use to interpret R squared value right here. Okay, that sentence. Okay. This sentence. Okay, you got to make sure you understand how to use it. Where we turn the R squared into a percentage by multiplying it by 100. Okay, and then we write this sentence, state the RV, write the rest of the sentence, then state the EV. Okay, that's how we interpret the R squared value. Just use that format. And then in 7G, we looked at trying to make a prediction using the formula. So normally, now that you have your formula right here, okay, you're asked to make some sort of prediction. Now we have two types of predictions. One is called interpolation. The other is called extrapolation. Okay, I think there's examples of it here. Interpolation and extrapolation. So interpolation is when you make a prediction and it's in the range and reliable. Okay, so it makes sense because it's within the given data. And the data that you're normally looking at is in here, the EV. So if your prediction is within this range, you should be right, and it's interpolation. But if you start making a prediction, say for example, this goes up to 400, and you start making a prediction at like 500 or 600, then it starts to get outside of the range because there's no data for it. Then it becomes extrapolation. So extrapolating means outside of the range, and that can go either way. That's either above the range or even below the range. So you can see if you make a prediction that's like 50, it's below the range already of where your data is. So your data is around here. When you start putting a prediction and you say, oh, what would happen if it was 50, which is there, then it's outside of the range. It's beyond this boundary here, okay, of this data. So the lowest here in terms of the range is about 100. So when you make a prediction that's less than 100, okay, it becomes extrapolation. And there's certain ways to interpret that, okay? If you make a prediction that is within the range, sorry, it's lagging a bit. Okay, so if you look at this here, air cons, okay, you've got the formula right here. Air con equals negative 38 plus 1.9 times temp. Now, they want to make a prediction of temperature if it's 24 degrees. So if you look at the range of the data here, it ranges from, I would say that's about 21 all the way to about 38. So if you make a prediction that's between 21 and 38, you should be okay. It should be interpolation. Now, temperature is within 21 and 38. So that's definitely within the range. It is interpolation. Sorry, 24, not 21. 24 is right here. So you're making a prediction of what would aircon be if the temperature was 24, which is here. So basically, what is the Y value over here? What is this value? Okay, that's that's the prediction. So if we make that prediction, we found out that if the temperature was 24 degrees, you would sell 7.6 aircons, which makes sense. So that's how we interpret it like this. The prediction where 7.6 aircons are sold, if the max temp is 24 degrees, is reliable. So you have to mention that it's reliable and it's interpolating and it's within the range. So those are three things you've got to mention when you're interpreting. Similarly, even if it's also extrapolating. So if you look at this extrapolating, you're making a prediction if temperature was 15, so 15 degrees. Okay, so if the temperature outside was 15, what would happen? Okay, so how many aircons would be sold? So using that formula, you change temperature to 15 and you figure out your answer, and it equals negative 9.5. Now that's weird because you cannot sell a negative amount of aircons. That would mean that they're giving air cons away, which doesn't make sense. So as a interpretation of that, the prediction of negative 9.5 air cons, which doesn't make sense, you can't sell negative air cons, if the max temp is 15, is unreliable, okay, because it's outside the range of extrapolating. Okay, so you have to mention extrapolating, outside, unreliable. Those are three things examiners want to see when you interpret these questions, okay? All right, so that's for interpolation and extrapolation. Let's now get into. Actually, do you want to do an example of it real quick? Maybe I'll do one real quick here. All right, just for you guys. All right, so here it's a little bit different. Comment on the reliability using the equation. Okay, so we're going to make a prediction on this. Okay, predict the number of red blood cells when the number of days of taking drugs is. So if you look at this already, I can see that the smallest is about 3.75. So that's here, this value. Okay, I'm going to assume that it's that. And the highest is about, I don't know, let's just say that's 8.75. Okay, so if I make a prediction outside of these values, it's going to be extrapolating. But if it's within, it's interpolating. Right, so the formula is this. I'm just going to go RBC for red blood cell count is equal to 157 plus 14.0 times number. I'll just go number of days to save some time. I'm not going to write the whole thing because I think you guys get it. So for the first prediction, we're trying to figure out a prediction for 6.5. Okay, so the number of red blood cells count. So on my formula, all I'm changing is 157 plus 14.0 times number of days, which is 6.5. So 6.5. Okay, that's the first part. So on my calculator, put that in. Okay, add the calculator. Just use your formula as you see. So it's going to be 157 plus 14.0 times 6.5. Okay, 248. Now, I don't actually know what's the normal red blood cell count, but it sounds normal, okay? 248 red blood cells. Anyone do bio here? Is that normal? Not sure. Okay, that's it. I think that's a normal amount of blood cells. So now, let's do the interpretation. Okay. So again, look at the sentence that I wrote in the previously. So write the prediction where, tell me the number, and then what's the variables and what's been happening, or what the actual context is. So the prediction of 248 RBC if what's the other one? Number of days. I'll just go number of drugs. Is what you would do actually though in the actual SAC is I would prefer if you wrote the full thing, the full variable, okay? Because that's what they want to see in year 12. Okay, but I'm just doing shorthand here because it's a lot. Number of drugs is 6.5 is accurate, or you could say, what did I put here? Is reliable, sorry. Because it is within the range. It is within the range. And therefore interpolating. Okay, notice that there's a slight difference of the way I use the sentence this time compared to last time. Okay, but again, it's still the same. Okay, I'm still using the same terms. Reliable. Okay, so talk about the actual variable that you calculated. What's the EV and the RV? Tell me about the number that you used to make that calculation. And then you have to talk about, is it reliable or unreliable? If it's in the range or outside the range, and if it's interpolating or extrapolating. Those three things need to be talked about. Hey.
Hey, sir.
Oh, yeah.
You should.
So, hey. Okay, the second prediction. Okay, so for B, you're making a prediction if the number of days was 20. Okay, so let's do B. Again, the formula was RBC is equal to 157 plus 14.0 times number of drugs. Okay, so number of drugs. Right, now the number of drugs according to this is going to be 20. So RBC is equal to 157 plus 14.0 times 20. So that's what's changing here now. Okay, times 20. So what does that equal? Okay, let's get our CAS out. Again, I'm just going to copy this, press enter, and that'll allow you to copy and paste it. So that's 437. Now, I don't know if that's normal, but it doesn't sound normal. So 437. Now remember, if you make a prediction outside of the range, it becomes unreliable. So interpreting this, the prediction of 437 RBC, if number of drugs is 20, okay, and again, because we know that the range is between 3.75 and 8.75, that prediction of 20 is way outside of that. So we say is unreliable. And extrapolating. Because it is outside of the range. Okay, so that's essentially what you need to talk about when you're interpreting this. So tell me what your prediction was. Give me the EV and the RV. So 20, unreliable, extrapolating, outside the range. Okay, it doesn't have to be in that order. You can see that my two answers there were slightly different, but they still talk about exactly the same thing. Okay, let's get into now 7H, which is the last chapter. So 7H, so we're at the very last few pages ahead. All right, so this is probably a lot easier than, actually this isn't too bad, but what I've noticed is in year 11, when people do this SAC for this, for some reason they always skip on interpreting the equations. Okay, so for this part of the lesson, or this part of the notes, we're going to get into interpreting the equation. Okay, that's basically the main thing. Interpreting the equation. Remember the equation, whenever you look at the equation for any of these things that we do, the regression line, okay, it always looks like this: y equals a plus bx. Remember, same as mx plus c, slightly different letters and numbers. X and y don't change. However, we now know that x is the EV, y is the RV, a is the y-intercept, and b is the slope. Okay, and it's mentioned there as well here. Okay, so if you can't remember what that all meant, make sure you read this. It's a good way to remember what is what. Okay, actually no, that's not what it's talking about. But this is what we're going to look at. So here is basically the way that you need to interpret this. So there's two things you have to interpret. You got to interpret A. Oops, sorry, wrong color. You have to interpret A, okay, which is going to be this sentence, and you got to interpret B, which is going to be this sentence. Okay, so you got to make sure you interpret both A and B. So for interpreting B, which is the slope in this case, you have to write the slope and tell me what's the value of that slope, which is going to be B. Estimates the average chance increase or decrease. So if it's a positive line or a positive slope, it's increase. If it's a negative line or a negative slope, it's going to decrease. Okay, so keep in mind of that sentence as well, or that part of it. In the response variable, so what's the RV? Okay, whatever the y variable is, for each 1 unit increase in the EV. Okay, so your sentence has to look exactly like this. Okay, it has to look like this. And then for A, if you're trying to interpret the y-intercept, which is A, the intercept, so tell me what's the y-intercept, estimates the average value of the response variable y, so tell me what's the RV, when the EV, okay, equals 0. So there's a couple of things you've got to do there, but I'll show you real quick on how to do it. Okay. Also, I like that they've included another way of interpreting it. So this is another way as well that you can actually do it. So the slope, remember the slope is going to be B and the intercept is A. So you're just interpreting those two values. What's A and what's B? For B, the regression line predicts that on average the RV, okay, tell me if it's increasing or decreasing. Remember, depending on the direction of it. And then tell me the slope for each 1 unit increase in the EV. And then for interpreting the y-intercept, okay, the regression line predicts that on average the RV is, what's the y-intercept? When the EV is 0. Okay, so let's actually, we can use either one. These ones look a bit more simple, so I might use that. So let's try to interpret them. Interpret the slope in terms of the variables and interpret the y-intercept. So for the first one, A, let's look at the formula for now. We know that here, in this formula, remember that's going to be y equals A plus bx. Okay, A plus bx. So that means that this is the y value or the y variable, which is the RV. This is the A, which is your y-intercept. This B here, okay, is going to be your slope, and this x is your EV. Okay, so we can now understand what's what in this formula. So in terms of interpreting the slope, okay, we're going to interpret the B value for now. So look at the sentence that we've used in the past. For the slope, the regression line predicts that. So let's start with that. You have to write your answer like that. Okay, so copying the sentence. The regression line predicts that on average the okay, tell me what's the RV. So in this case, the RV is that y variable there. Might change the level. So the number of members. Okay, looking at the sentence as well. Okay, it helps you to actually understand what's happening. So the number of members, is it increasing or is it decreasing? Now look at the variable. Look at the actual B value. Is it positive or negative? It's positive, so it's increasing. So you'll write the number of members increases. Okay, continuing on, increases by, okay, now you're telling me what is the actual slope value. So the slope value here is 14.795. Okay, so you tell me that. Again, look at the sentence. By the slope for each unit, so each, you could say in this case, 1, okay, 1's fine, increase in the EV. So for each 1 unit increase, in the, and then tell me what's the EV. In this case, it's money spent on advertising. Now for that each 1 unit part, sometimes a formula might not tell you what the units are, but in this case, it's millions. So you can actually say each million in increase for this in this context, okay? But sometimes some formulas won't be that clear. So you can actually just write 1 unit, that's fine. Okay, cool. All right, let's interpret the B variable, or the B. Let's interpret the, it's very confusing, the y-intercept, which is A in this case. Yeah, so now you're going to interpret A. Okay, again, use that sentence. So the regression line predicts that on average. Let's start with that. So for that one, the regression line predicts that on average, okay, looking at the sentence, on average, the RV is, and then what's the y-intercept? So fix that, the RV. So don't write RV. You have to tell me what the RV is. So the RV in this case is number of members. Okay, is, and I'm going to say is, yep, the intercept. So is, and then tell me the y-intercept, which in this case is 42956. Okay, finishing it off with the rest of the sentence. When the EV is 0. So when the EV, tell me the EV, money spent on advertising. On advertising is 0. Okay, and that's how you interpret your y-intercept and your gradient or your slope. Okay, does that make sense, guys? Any questions? The easy thing with this is you just follow the format of the sentence. That's it. And then just change the variables and the numbers. That's all you got to do for interpretation. Okay.